Yes. So, hello everyone. So, today we are going to discuss kinematics, the part 2 video. Remember, in the part 1, we had already discussed about the speed, velocity, acceleration, instantaneous, and average of all that. So, now we'll discuss a little bit about graph and some problems also based on the previous video. Okay. So, graphical terms, I'll start in this way that let us start with displacement versus time graph, right? Let us think about that. So this is, let us say, displacement in terms of x, I'm showing y-axis, and time t, I'm showing. So if I show you, let us say, a graph of displacement versus time as a horizontal straight line. So what's the meaning of that? So we have to understand, right? For JE students especially, okay, yes, for NEET students also, but specifically for JE students, the understanding of graph is very, very, very important. Okay, and NEET students also, it is important because from nowadays, recent years, the NEET examination paper has become slightly more difficult side for the physics, right? So make sure that you understand all this mathematical part also properly. So this is pretty easy graph actually. What that means is the x of the particle, as the time is changing, the x of the particle is always remaining the same value. It's not changing. So if x is not changing, that means the particle is not moving from that position, right? Because x is nothing but position of the particle. With the time, the position is not changing. So what we can say? We can say that the speed of the particle is zero. That's what I can say. Overall, everywhere you are finding that the same position it is maintaining. So the particle has not even started moving. The particle is at rest. That's the meaning, right? Now, what if I change the diagram? What if I give you a different kind of graph? For example, let us say my graph is starting from origin like this. I could give. Now, according to this blue colored graph, what do we understand? That at time t equal to 0, the particle was at x equal to 0. So, at t equal to 0, the particle was at x equal to 0. Okay. After some time, as the time increased, my particle's position also keep on changing. Very good. So, that means the particle is at least not at rest. The particle is moving. Now, once the particle starts moving, the question comes, what is the speed? Is the speed changing? Is it remaining constant? If it is changing, how it is changing? This kind of questions will come. So if you look at this graph, we can understand one thing based on this, that the graph is basically a line, a straight line I have drawn. And in x versus t graph, in x versus t graph, delta x by delta t, which is nothing but basically what I'm doing is the y-axis by the x-axis, delta y-axis by the delta x-axis. This always represents what? Slope. Okay, y-axis by x-axis, the change that is representing always the slope. And we know from the previous video that delta x by delta t represents what? It represents the speed or velocity, we can say, right? So I can say average velocity, because I am calling the x as the position. So change in position gives me displacement. That's why I'm calling it as average velocity. Okay. Now what if I don't calculate delta x by delta t? What if I go by the concept of dx by dt? What if I calculate dx by dt? Then that also comes similar to dy by dx. Those of you who have studied basic maths, you understand that dy by dx is nothing but same as delta y by dx. That is also representing what? Slope. The only difference is when you do delta, you're talking about average slope. The moment you do dy by dx, you're talking about the local, the instantaneous at that position, the slope, like that. Okay. So this is also slope. And from the previous video again, you know what is this value? This is nothing but instantaneous velocity. Okay, this is instantaneous velocity, this is average velocity. Simple. Now what can you say about the slope of a line? It's a line in our case, right? So delta x, if you want to find out, you have to take, let us say, two positions, x1, x2. Correspondingly, you have to take two time values, t1 and t2. So you have taken two time values. and also you have got 2x values. Now this delta x, the change, right? This value, the delta x divided by the delta t. This is basically the slope, okay, which is basically average velocity. If you find out in the same way dx by dt, but the good thing is for a line, the dx by dt and the delta x by delta t both are same only, so it doesn't matter, right? Okay, what if I show you a different graph this time? Let's say x-axis and y-axis is remaining same. It is x, it is t, same position and the time. But what if my graph is this way? What would this mean? So again, obvious thing, at time t equal to 0, position is at t equal to 0, my position is 0. After that, the position keeps changing, but we can obviously see compared to this blue line that is different because this was a line, that is a curve. And when it is a curve, then my velocity, which is nothing but the slope, that is not constant. Here the velocity is remaining constant throughout. Why? Because for a line the slope always remains constant. Wherever you go, the slope is same. The tangent drawn at the curve always represents slope. So I'm drawing the tangent. They're exactly the same everywhere. Whereas when I come here, if I draw tangent at this location, look at the orientation of the tangent. If I draw the tangent here, look how it has changed. If I draw tangent here, look how it has changed. So the tangent keeps changing, right? What can you say about the slope of this curve? Look at the slope. The slope means it is nothing but steepness. I tell to my students that whenever you are having confusion in understanding slope, think of it as the steepness of the curve. Initially, the steepness was less, but eventually the steepness of the curve is increasing. And steepness in our case is slope. So I can say in this diagram, the slope is increasing with time. The slope is continuously increasing with the time. And what is slope? Velocity. So final thing, that means velocity is increasing with time. Okay. So because the slope is increasing with time, I can also say that velocity is increasing with time in that case. Right? Very simple. Okay. What if the graph was in a different way? What if the graph was like this? Second case, the blue colored line. There also we can say the same thing as the first one. At t equal to 0, x is equal to 0. What also you can say? The slope of this graph. Look at the slope. Initially my slope, the tangent will look like this. Then the tangent is looking like this. Afterwards the tangent is looking like this. Okay. So what can we understand from here? The tangent is changing its orientation, and how it is changing, we can say the steepness of my curve is actually decreasing. It is becoming lesser and lesser steep. If it is becoming lesser and lesser steep, what we can say? That the slope is decreasing with time, and also slope represents velocity. So finally velocity is decreasing with time. That's okay. Simple, very simple concept. So this is a discussion based on the displacement versus time graph. Okay. More important than displacement versus time graph is actually velocity versus time graph, because by using displacement I can only calculate the velocity, right? Acceleration becomes slightly more tricky because then I have to find out what is the rate of change of velocity and etc. But it's always easy to identify velocity from the x versus t graph. But when you go to v versus t graph, you can find both acceleration from there as well as you can find out the displacement from there. So that's why most examination questions prefer giving velocity versus time. Okay. Anyway, we'll discuss about that in a little further. Before going for that next diagram, what can you say about the acceleration in this case? That is a black colored line. What can you say about the acceleration? Is there an acceleration? Acceleration depends on what is the velocity changing. So is my velocity changing? Yes. Velocity is increasing with time. So if velocity is increasing, definitely there is an acceleration and it's a positive acceleration, right? Now, in this case, the velocity is decreasing with time. That means there is acceleration, but it's a negative. We call it as deceleration. When you come to this blue colored straight line, what can you say about that? The velocity is remaining constant because it's a straight line. Slope is constant. Velocity is remaining constant. Right? I should have mentioned here that slope is, for this case, we can say that the slope is constant. And slope is nothing but velocity. So velocity is constant. So what about acceleration? 0. Okay. What about this case? The body itself is at rest. Continuously it is at rest as the time increases. So there is no acceleration. There is no velocity. Are we clear with this? This is the first part. Okay. Now let us go for the second part. That is, I want to draw the diagram for V versus T. Let's go for that. Same kind of diagram I'll draw, exactly same way. Let us see what will happen in that case. Okay. Okay. What if, let us say, it's a VT graph. So I have a VT graph in this way. This is velocity versus time. Now in this graph, let us say I have a first graph like this horizontal line. Conclusion, at t equal to 0, why t equal to 0, right? Always. Why to talk about even t equal to 0? Because this graph is a constant. So we can say that my v is equal to a constant value. Let us say this is v naught. So v is equal to v naught forever. That's it. Whatever the time may be, velocity is remaining constant. If velocity is constant, what can you say about acceleration? 0. So conclusion is acceleration equal to 0. As simple as that. Okay. Another important thing. If you know velocity is constant, then can you also find displacement pretty easily? Because if velocity is constant, we can say v is equals to displacement delta x by the delta t. So delta x would be nothing but v into t. In our case, the v is nothing but v naught. So very easily I can find out the displacement. Also, in basic maths you have studied that whenever a graph is given, then the y-axis into x-axis, okay, that always represents area. So for example, I can say from this given data that at different time intervals t1 and t2, different time moments t1 and t2, basically I'm talking about this gap as the delta t. So during the delta t interval, if I am interested in finding the displacement, I can go with the area under my graph. Look at this. Yes, this t is nothing but the time interval, right? I will just represent that here. T is the delta t, the time interval. So I can represent this as delta t. So area under my graph here represents, this blue colored part represents the displacement in that much time. Right? Look at this. It's a rectangle. The base of the rectangle represents delta t. The height of the rectangle represents v naught. So this area v into delta t is basically representing as the displacement of the particle. So this is very important in a VT graph. So in a VT graph, the slope always represents acceleration and the area under the graph always represents the displacement. Okay, this has to be very clear. So this was first case, case number 1. What if I go for, let's say, next case? This was first diagram. What if I go for another diagram? This time I am drawing the diagram, let us say, in this way. It's also VT graph. Then what would be my conclusion? My conclusion here would be that at t equal to 0, what can I say? V is equal to 0. But as time increases, my velocity just keeps on increasing. Okay, good. So what can I say about the acceleration? Acceleration in VT graph is nothing but the slope, right? So can we talk about slope? The slope is equals to, the correct formula, the correct way of saying it is dv by dt in this. Basically, I'm talking about the dv. Remember dy by dx. This can be written also as dy by dx, y-axis by x-axis, like that. I already showed that to you, right? Okay. Anyway, and what is this dv by dt? Doesn't it represent the acceleration? Acceleration. Okay. It is representing acceleration. But that means the slope, which is acceleration, because it's a straight line, it equal to constant. That's it. Okay. So if this kind of a graph is there, then as per this graph, the slope is constant because it's a line. So acceleration, which is the slope, will be constant. What if I want to find out displacement? In V versus T graph, displacement is nothing but the area under the curve. So this is my curve. Area under the curve, I need to find out. So basically, I would be requiring displacement for two time interval, right? Two time values. So this is the T1 and this is T2. So between time T1 and between time T2, I am interested in finding the time interval. I am interested in finding displacement. So again, I have to go with what? The area of the graph under. That's it. Find this area. This area would give you displacement. Okay. Because the acceleration is constant, you can even use the constant acceleration formula. That is v is equal to u plus at, s is equal to ut plus half at square, v square minus u square equal to 2a. Any of these three formulas, any of them. Like in our case, I know velocity and time, so definitely I should be using v is equal to u plus at, or because I want displacement, I should use s is equal to ut plus half at square. That formula I can use. By using that formula, I will be able to find out displacement. It will come out to be exactly the same value. So the point that we have to understand here is conclusion is that area under the graph in a VT graph always represents velocity, displacement, and slope of the graph always represents acceleration. The simple thing only I'm interested in making you understand. And one last graph I'll show you where I'll be having curved case. This is V versus T. And if this kind of a graph is there, graph 1, and what if you have this kind of a graph 2? What can you say about this thing? So again, pretty easy. In the first graph, what is happening to the slope? The slope is increasing. And what does the slope represent here? Acceleration. So can I say for the graph 1, A is increasing? Correct? This is just representing an upward arrow. Upward arrow represents that A is increasing. What about the second case, the second graph? In the second graph also, it is V versus T, so slope represents basically acceleration. What is happening to the slope? The slope is basically decreasing. We discussed for the velocity in the X versus T graph, we discussed this, right? So here also the tangent, the slope is just decreasing. If it is decreasing, slope is nothing but acceleration, so acceleration is decreasing. Okay, as simple as that. Both of them are accelerated motions. Don't say that this is deceleration. No. Okay, still the acceleration is there and that acceleration is a positive value. If acceleration is positive, then definitely it will be called as acceleration and not deceleration. So both the motions are accelerated, but here acceleration is increasing and here the acceleration is decreasing. As simple as that. I hope you have understood this basic idea. Okay, fine. So these are about the graphical representations. So whenever you will be getting any of this graph, we can also draw acceleration versus time graph. Based on the simple idea, I think you understand that if I have an acceleration versus time graph, just for your knowledge, if I have an acceleration versus time graph, and if I draw a line, let us say, just representing a curve, then the area under this acceleration versus time, what would that give me? Very important. Why very important? Because I know many students will make mistake here. What is the area under this graph? Time is t1, time is t2. The time interval we are calling it as delta t. I am interested in finding this. What is this area? So many students will right now say that, sir, it is velocity, but that's wrong, right? What is acceleration formula? A is equals to delta V by delta T, right? So when you cross multiply this, you'll be getting delta V is equals to A delta T, right? A delta t is nothing but the area under the graph. That A delta t value is coming out to be delta V. So the point is, area under the graph of A and T does not represent velocity, it represents change in velocity. Very, very important. Change in velocity. Please remember this. Okay. Same way in velocity versus time graph, the area under the curve represented what? The area under the curve is actually representing change in position. The change in position, we are calling it as displacement, like that. Okay, I hope you have understood. So this is the understanding about the graph. Okay, we will be solving one question also based on this in the next video. Just make sure that you understand the graphical method. I tell this to all my students, whether they are for preparing for JEE or they are preparing for the NEET examination. For both these cases, graphical questions are very, very important. If not in this question of kinematics, in some other chapters, it will be definitely coming. So you have to be careful with only two things when you look at the graph. Number one, look at the slope. Identify what is the meaning of the slope in the graph. For some cases, slope will be having no meaning. Like for example, if you go for acceleration versus time graph, what's the meaning of the slope here? Slope will be what? Delta A by delta T. It's called a jerk actually, but in our syllabus it's not there. But that means the slope of this area versus, sorry, acceleration versus time graph has no meaning for us. But in velocity versus time graph and displacement versus time graph, the slopes have meaning, right? Similarly, if you go to displacement versus time graph, what's the meaning of area under the curve? There's no meaning. Displacement into time, we are studying nothing like that. But that means the area under the curve has no meaning there in displacement versus time. But here, in velocity versus time and acceleration versus time, area under the curve have meaning. So in whichever chapter we are, for graph, you have to just identify these two things. What does the slope mean? What does the area mean? Using this, 99% of questions of our competitive exam, we can pretty easily solve. Okay, so I hope you are clear with this. In the next video, we'll be solving one question. Using this, we'll be understanding all kind of concepts based on instantaneous velocities, average velocity, how the curve would be looking like, and etc. All these things. Okay, so we'll stop here then. Thank you.